Educational Saudi Arabia potential by now.
Morning, everyone. We'll get started for today's session. I hope you had a very restive night and sleep yesterday. And we're looking forward for today's session. I have a small announcement to make. It's an important one. So as you know, we are going to give you certificates, participation certificates for the conference. And for what we're planning to do is the country coordinators or we'll have a list of all your names as it will appear on the certificate. So please check for any mistakes in spelling or the place where you belong from. So what we're going to put on the certificate is your name and your affiliation, that you're from this institute or this from research university and things like that. And your country flag will be there. So make sure you check all these things clearly. Your designation, whether you're a professor or doctor, those things we are not putting. Only name, your affiliation to university or research institute, and we are going to put what your country's flag is. Make sure we get it right. So Deepam is raising his hand up there. He's going to come with you with printouts. These are dummy printouts, black and white, just for you to check. So if you say okay, then we will go and make the correct ones. If there is a mistake, you can say what the mistake is. They will correct in the soft copy there, and we'll go for printout. This has to go out by 11 today, so please help us in giving your answers, okay? So with that, we'll get started with the first session today.
Very good morning to everyone. I welcome you to the 4th day of Shanghai Cooperation Organization Young Scientist Conclave 2023. The theme for the day is Environmental Protection and Natural Resource Management. Environmental protection and natural resource management are the basic principles for the overall development and sustainability of a nation. The prominence of this research domain is vast, as it directly deals with ecosystem and sustainability studies, including but not limited to pollution, flooding, biodiversity conservation, nuclear energy, drought, coastal restoration, and the mission to mitigate the potential adverse effects of mismanagement. Effective natural resource management amidst the SCO nations is possible upon achieving the milestones of improved resource governance and sustainability, amplified responsibility, and increased involvement of the SCO members in the cross-border R&D projects to resolve the shared environmental and resource management disputes by tactical mechanism. This thematic area aims to promote research alliance in all aspects of environmental and natural resources protection among the SCO member states. Today's session is co-chaired by Professor M. Eshkurbonov and Professor Sebastian C. Peter. Professor Eshkurbonov joined JNCSR as a faculty fellow in 2004 and has been a professor since 2016 in the Chemistry and Physics of Materials unit. The current research focus of his group is the synthesis of nanomaterials for application in industrially relevant catalytic processes, electrocatalysis, electrochemical energy storage, membrane-based gas separation, and drug delivery. Our next co-chair, Professor Peter, joined JNCSR Bangalore in 2010 as a Ramanujan Fellow and has been an associate professor since 2017 in New Chemistry Unit. His research interests include fuel cells, water splitting, and CO2 reduction. Apart from fundamental research, Professor Peter is involved in translational research and is the founder and director of the startup Breath India Private Limited, which aims to convert CO2 into chemicals and fuels. We would like to inform you that during the talks, for both virtual participants and speakers present here among us, we shall be streaming your live videos next to your PowerPoint presentations. For speakers present with us here, You may please raise your hands to identify yourselves while your presentations are played so that the camera may capture you. Virtual participants are requested to turn on their cameras while your presentations are live streamed. There's a question and answer session at the end where we'll take questions from both virtual and in-person participants. For asking questions, the participants here may raise their hands and our volunteers will come to you with a mic. For the online participants, kindly type in your questions in the chat box and we'll take them at the end of the entire session. I would like to now start with the session. And our first speaker is Yuting, lecturer, Hubei University of Technology, China. And the title of their talk is Sensitive Detection for Environmental Hazardous Materials by SERS Optical Fiber Probe Sensor.
Greetings, ladies and gentlemen. It's a pleasure to share my research work in this conclave. Today, I want to talk about a sensitive method to detect environmental hazardous materials by using SERS optical fiber probe sensor. First, I will give a brief introduction of the SERS optical fiber. Based on the introduction, I will share some examples of sensitive detection for environmental hazardous materials, and in the end, summarize the general ideas of the talk. As you can see, organic dye waste and heavy metals are extremely toxic, not only to the human beings but also to the environment. Therefore, sensitive detection for these hazardous materials is essential for environmental monitoring and protection. Among all of the sensitive detection methods, SERS, or Surface-Enhanced Raman Scattering, shows its advantage. When we incorporate SERS active material on flexible optical fiber, an optical fiber probe is obtained. Here, we utilize SERS optical fiber for hazardous environment detection, as it offers real-time, in-situ flexible and sensitive detection. And how do we detect the analyte? The detection process is very simple. When we obtain the SERS fiber probe, that is to incorporate SERS active materials on the facet of optical fiber, the SERS signal will be obtained when the probe is mounted on the Raman spectroscopy with the other end dipped to the analyte. Just a single dip for detection, very simple. And how does this probe sensor work? As you can see here, the laser light emitted by the Raman spectrometer coupled to the fiber transmitted to the distal end, and as the laser light interacts with the SERS active material at certain conditions, the SERS effect will occur and amplify Raman signals by orders of magnitude. The SERS signal will be transmitted back to the Raman spectrometer, therefore realize sensitive detection, because the Raman signal is extremely amplified. So, the first example for sensitive detection for environment hazardous material is organic dye in confined area. Here we use rhodamine 6G as an organic dye which is highly toxic, corrosive, and environmental hazardous. The first challenge for the probe fabrication is the feasibility. It is important to address the interfacial bonding due to the incompatibility between the silica and the SERS active material, as we use silver nanoparticle here. So we put up a stainless chloride sensitization method to pre-treat the fiber. This method provides sufficient interfacial bonding. as the stainless chloride connected to the optical fiber due to electrostatic attraction, and also bonds to the silver due to similar metallic bonds. After solving the interfacial bonding, we successfully fabricated the SERS fiber probe, as you can see. Here, the fiber probe easily passes through the holes with diameter less than 1 mm and approaches the analyte, realize sensitive detection in real time in confined area. The second example is sensitive detection of organic dye through the curved channel. The probe shows its flexibility, which passes through the curved channel and detected the analyte at low concentration. The third example is the sensitive detection of heavy metal, namely hexagonate chromium. As the analyte will not anchor on the surface of silver spontaneously, special functionalization is to be designed to selectively detect molecules. In this case, hexagonate chromium is detected with the aid of multimazole. Briefly, silver nanoparticles are coated on the fiber according to the previously used method. Then the multimazole was specially introduced and anchored on the silver nanoparticles, while the silver-sulfur bond or the nitrogen-silver bond. The multimazole also functions as the Raman reporter when the detection molecule hexagonate chromium appears. In detail, the source intensity of multimazole will reduce when chromium appears, as the multimazole reacted with hexagonate chromium and peels off from the optical fiber probe. In a nutshell, the hexagonate chromium will be seen with the source intensity reduction of the multimazole. The specially designed method was validated as the source intensity only decreases when the hexagonate chromium contacted with the fiber coated with silver and multimazole. This method shows ultra-high sensitivity for the hexagonate chromium detection. Detection limit is 10 to the minus 11th mole per liter. Plus, the fiber probe exhibits good reproducibility with the RSD of 8%. In summary, a sensitive detection of various hazardous materials, including organic dye and heavy metals, are realized by SERS optical fiber probe. We also found it available in some hazardous environments, such as confined area, curved channels, and real-time detection. With the functionalization of SERS optical fiber, we further plan to detect more complicated situations, such as real-time sensitive detection in lakes and rivers. And last but not least, thanks for the cooperators and the funding, and thank you for your attention.
Thank you for the wonderful talk. We'll now move on to the next talk by Kalashnikova Galina Olegovna, the head of the Laboratory of Synthesis and Research of Mineral-like Functional Materials of the Nanomaterial Science Center, Kola Science Center of the Russian Academy of Sciences. The title of their talk is Natural Minerals of the Lintisite Group as the Base for Creating a Multifunctional Nano-Puzzle. I request you to raise your hand if you're here.
Good afternoon, dear participants of the second SCO Young Scientists Conclave. My name is Galina Kalashnikova and I am the scientist from the Kola Science Center of the Russian Academy of Science. First of all, I'd like to appreciate the organizers of this event for the chance to introduce for your attention one of the projects of our team, which, as you can see from this slide, includes specialists from different institutes and areas of the science. It's the St. Petersburg University, the Research Park of St. Petersburg University, Novosibirsk State Technical University, and Institute of Physical Chemistry and Electrochemistry. The name of the project is the natural minerals of the Lintisite group at the base for creating a multifunctional nano-puzzle. Our center is situated on the Kola Peninsula in the northern part of our country and located beyond the Arctic Circle, near the Hibini Mountains. And we have a great chance to work with the nature material, investigate mineral processing processes, synthesize the synthetic analogues of the most interesting samples of nature minerals with useful properties for the field of science, technology, radiochemistry, catalysis, and the medicine. That's why our center includes 11 institutes with different specifics of the work. In this report, I'd like to introduce you the useful properties one of the group of rare minerals. The name of this group is Caucasumite Lintisite family, and this group includes 5 different minerals. All of them you can see on this slide. It's Lintisite, Caucasumite, Mangano-Caucasumite, Punkoryoite, and Yelisivite. All of these minerals have a very similar chemical compound, and besides they have a similar crystal structure. For example, on this slide you can see 2 crystal structures, for Caucasumite on the left side and for Lintisite on the right side. Crystal structures of these minerals are based upon 2-dimensional titanium-silicate nanolayers consisting of pyroxene-like silicon oxides chains and brookite-like chains of titanium oxide octahedra. The layers are linked into a 3-dimensional framework by cross-linking cations. For example, in Caucasumite it is zinc cations, and for Lintisite it's lithium cations. As a result, the crystal structure of these minerals has wide open channels with crystallographic diameter near 4 angstrom. The chains in these materials may have 2 possible orientations related by 180-degree rotation and denoted in C and D orientation as plus or minus. And you can see from this figure that for Caucasumite, for example, orientations of chains have positive and negative orientations. As in contrast, all octahedral chains in the crystal structure of Lintisite are in the same orientation. Remarkable that after treatment, these crystals with acid solution, they lose all water molecules and cross-linking cations from their structure, without any change of shape or color of initial mineral. These 2 facts about the crystal structure of these materials proved to be very useful for modeling the basic properties of the material for its application in the further field of heterogeneous catalysis. Crystal structures of both substances are based upon the same titanium silicate layers, but with different orientation and displacement relative to each other. It's noteworthy that crystals conserve their 3-dimensional integrity after ion removal single crystal to single crystal transformation, despite the fact that in the course of treatment layers are shifted by 5 angstrom. For nowadays, we can find the information about the synthetic analog of this minerals group for only one synthetic analog. It's AIM4, and as you can see from this slide, this material have a very similar crystal structure as its minerals analogs. It was synthesized for the first time by the Dadashev group in the 1997 on the basis of clean chemical reagents, and in the case of our work we try to find the ways to obtain this material on the basis of technique salts, and in the case of titanium sources we try to use the intermediate product of sphin and laperite concentrate processings. It's 2 salts, for example titanium ammonium sulfate, this, and tetrachloride of titanium. In the case of the synthesis AIM4 from technical salts, it was a lot of different problems with the reproduction of literature method. The main problem was to obtain the monophase of the AM4, but the problem was solved after selecting optimal conditions for multi-stage recrystallization of the product. When we have obtained the synthetic material on the base of technique titanium sources and transformed its crystal structure into new substance with nano-puzzle construction, we start to test its useful properties in different areas. First of all, it was under the question functional materials, such as recyclable sorbents, photocatalysts and heterocatalysts, materials with biocide activity, different sorbents for radioisotopes, and matrices for energy sources. Areas in which it was possible to experimentally confirm the useful properties of the material are highlighted in green. Let me know the most interesting results. It's remarkable that new titanium-silicate material has a high sorption properties against cesium from the liquid radioactive waste solutions. Besides, it's possible to turn the material with cesium into a stable, nature-like ceramics. It was a discovering for us that this material has a good characteristics for the organic synthesis, like a heterogeneous catalyst, and the example of such synthesis is the reaction of anticonvulsants drugs obtained. Also, this material can be used as the special matrix for amidazyl particles, and after such modification, it's possible to use this substance for the synthesis reaction of propylene carbonate from propylene oxide and carbon dioxide. The specific surface and crystal structure of the new material allows to regulate its catalytic properties for the reaction of obtaining a milder solvent for printing inks and enamels. It's important for practical application to obtain useful sorbents and other materials in granular form. In case of synthetic analog of lintisite group, we can apply the wide range of instruments. It can be fluidized bed unit, centrifugal granulator, or screw rotor granulator. I'd like to conclude the report with some important points. Transformation of lintisite crystal structure in synthetic particles has a single crystal to single crystal character. This transformation is reversible and polycyclic. All substances are stable in acidic media. It's possible to obtain this new nano-puzzle material on the base of technique titanium sources. The new compound has a wide range of practical application. Thank you for your attention. If you have any question, I will be glad to answer it. We also look forward to new collaborations. Thank you.
That was a wonderful talk. Thank you. We'll now move to the next speaker, Shiqing Wang, Senior Research Engineer, Huaneng Clean Energy Research Institute, China. And the title of their talk is The Development and Demonstration of a Novel Multipollutant Control Technology, Huaneng COAP. I kindly request you to switch on your camera.
Hi everyone, my name is Shiqing Wang and I'm from China Huaneng Group. And this is the topic I'm going to introduce today, the development and the demonstration of a novel multi-pollutant control technology, Huaneng COAP. First, who we are. Huaneng Group is one of the largest power companies in China, and Huaneng Theory is a clean energy research institution of China Huaneng Group. We focus on renewable energy and clean coal technology as well. And nowadays, coal is still the dominant energy source in China and causes a lot of pollution issues. From 2014, China has implemented super ultra-low emission standard in coal-fired power plants. The limit for SO2 emission is 35 milligram per cubic meter, and for NOx is 50, for particulate matter is 10. So far, more than 93% of the power unit has adopted super ultra-low emission standard. And as you can see from this figure, that the reduction of the major pollutant from 2014 to 2020 is preeminent. And as you all know, that the traditional pollutant control technology usually composed of a SCR-D NOx system, ESP-D duct system, and a FGD-D SOx system. For this technology, the major problem is that they consume a lot of chemicals, such as limestone, ammonia. The consumption of these chemicals usually lead to a lot of secondary emissions, such as escaped ammonia, wastewater, catalyst waste as well. And this is a process diagram of Huaneng COAP technology. COAP is the initial for cold oxidation adsorption process. In this process, flue gas is first cooled down to sub-zero temperatures through a multi-stage cooling system. And SO2, NOx, and other pollutants are removed through a adsorption and a desorption system. The dissolved SO2 is converted to sulfuric acid or its salt. NOx is recycled to the burner to form a new balance between nitrogen and NOx. The target for COAP technology is to reduce the major pollutants such as particulate matter, SO2, and NOx to below 1 milligram per cubic meter. In our study of COAP technology, its major finding is that nitrogen monoxide, NO, which is difficult to be absorbed normally, can be effectively absorbed at cold temperatures with a large capacity, as you can see from this table. In addition, SO2 can be also absorbed with a large capacity at cold temperature as well. In the past few years, we have built several validation platforms and demonstration plants for COAP technology. In 2020, we have built a pilot validation platform in Huaneng Yueyang power plant. The flue gas capacity is about 3,000 cubic meters per hour. The inlet flue gas has a SO2 concentration about 3,000 and the NOx concentration about 200. And the treated flue gas has a SO2 emission and a NOx emission below 1 milligram per cubic meters. And the emission for particulate matter is below 2 milligram per cubic meters. In addition, the removal efficiency for other pollutants such as hydrogen chloride, SO3, mercury is also very high. It's higher than 97%. In 2022, last year, we have built a demonstration plant for COAP technology in a chemical plant. The flue gas capacity is 50,000 cubic meters per hour from a gas burner. And the treated flue gas also has a SO2 and a NOx emission below 1 milligram per cubic meter. And this is a demonstration project we are currently working on. And this project is built in a power plant. The flue gas has a capacity about 500,000 cubic meters per hour from a 135 megawatt coal-fired unit. And the inlet flue gas has a very high SO2 and NOx concentration. And we have a design value for the treated flue gas that SO2, NOx, and PM has an emission lower than 1 milligram per cubic meter. In this project, SO2 is converted to a sulfuric salt, which has a market value. And this project is going to be accomplished in 2023, this year. And this is a comparison between the traditional technology and the COAP technology in terms of CAPEX and OPEX. As you can see that so far that COPEX, the COAP technology still has a higher CAPEX than the traditional technology, but has a lower operation cost. So far, our team has applied more than 100 patents, including 9 international patents and more than 40 China patents. We have also have several publications regarding our recent work. In 2021, Huaneng COAP is selected as one of China's leading technology in environmental protection area. And in 2022, last year, Huaneng COAP technology is selected as one of the introducing technology in ZGC Forum opening ceremony, which was postponed due to the epidemic situation. And ZGC Forum is one of the very high-level forum in China. And this is all I'm going to introduce today. Thank you for your time.
Thank you for that wonderful talk. We'll move on to the next speaker for today, Mingkai Jiang, Principal Investigator, College of Life Sciences, Jiang University. And the title of their talk is, Can Phosphorus-Limited forests sequester additional carbon under elevated atmospheric carbon dioxide in the future? I request you to please switch on your camera.
Hello, everybody. Thank you for coming to my presentation and for this opportunity to allow me to present at this computational carbon on the elevated CO2 in the future. So firstly, a little bit of self-introduction. I'm a terrestrial ecosystem ecologist, and I'm a professor at Zhejiang University. My research interests cover a whole spectrum of field in ecology. In particular, I'm interested in global change ecology, the terrestrial carbon cycling, and data model integration. I have first author publications in well-reputational journals such as Nature and Nature Geoscience, etc. I'm also a subject matter editor at Ecological Applications. For more details of my background, please see this webpage. So a little bit background on this talk. Firstly, we know that as the atmospheric CO2 concentration rise, it will lead to additional plant growth. And therefore, it has been shown globally that there's a global greening trend due to the CO2 fertilization effect. But regarding the future trajectory, we know relatively little, and we have a large uncertainty regarding whether the land can continue to sequester additional carbon in the future. So one of the major crucial aspects that the models need to consider for predicting future carbon sink is phosphorus limitation, P limitation. Globally, P limitation is widespread, and it has been shown that by including the P limitation in the models, the CO2 fertilization effect is reduced. But there are a lot of model assumptions that are different among different models, and therefore we need to evaluate the model predictions based on data. So the purpose of my research is to understand to what extent does P availability limit ecosystem carbon cycle responses to elevated CO2. I want to use models to understand the trajectory and magnitude of the CO2 fertilization effect. And I want to use models to understand what are the mechanisms underpinning the different predictions so that I can guide future data collections. My research based on, for this particular research, it is based on the eucalyptus free air CO2 enrichment experiment, EUCFIS, which is located in Australia. So the experiment has been ongoing since 2012, and it was subject to CO2 concentration treatment of plus 150 parts per million above the A-band concentration. The soil is low in P availability, but it is not uniquely low, and which is representative of our global range of forests. Plant growth has been shown to be limited by soil P availability. What I did before was I constructed an ecosystem carbon budget on the both A-band and elevated CO2 concentration. And I showed that plants actually increased their carbon uptake, but they did not grow extra biomass. Instead, they used the extra carbon and invest that active carbon into the below ground to trade for nutrients in the soil. So what we want to do in this particular research is to use models to understand what are the P-cycle limitation on the CO2 effect. So included in this is an international collaboration. I included in total 6 different CMP carbon, nitrogen, and phosphorus models. And there are 2 more advanced microbial modules as well. So in total, we have 8 models. All the models include the P-cycle processes, and we run the model for a period between 2020 and 2069 under a range of P addition experiment in the model. So what the models are showing here is that the P addition only led to a small gross primary production, which is carbon uptake by plants, GPP increase. Similarly, we see a very small increase in biomass production increase and plant P uptake increases. So we want to understand why that is the case. So we trace the fate of the actual P added into the ecosystem. What we see is that most of the models are most of the extra P ended up in soil, but there are also models predicting that there's an ecosystem P lost, which would have implications for eutrophication in downstream. And some models actually predicted an increased plant P pool, so that we can see it's possible that when you add more P, plant will take up extra P. But in most of the models, actually, the additional P would end up in the non-labile pool in soil, which means that this P will not be available for plants. And therefore, the relative weak P fertilization effect could be due to a combination of the reasons listed here. For example, there will be a non-labile P accumulation in the soil, or there could be rapid P losses from the ecosystem, or that the system will become unlimited, nitrogen limited with P addition. Now we want to understand what's the implication for the CO2 fertilization effect when we add different levels of P addition. And what we see is that the results do not agree with the general potted-based experiment compiled globally. What you see, for example, is that for photosynthesis, models generally predicted the largest CO2 effect on gross primary production with no P addition, whereas in the data performed in potted experiments show that the eCO2 effect on photosynthesis was significantly dampened by low P availability. A similar message was shown for biomass growth as well. So to conclude, what we see from the models is that the P addition will lead to some positive biomass increase, but the P addition may not lead to additional carbon responses, CO2 responses. And we see a different results, contradicting results on the P-CO2 interaction. And this also highlights the need for more field-based data to actually reject or support the model-based hypothesis. With that, I want to acknowledge all the contributions from different institutes located globally and all the modelers who contributed to this work.
Thank you for your talk. We'll now move on to the 5th speaker, Elmira Orynbassarova, Research Supervisor at the Kazakh National Technical University, Kazakhstan. The title of their talk is Remote Sensing and GIS Technologies for Eco-Mining. I request you to please raise your hand.
Hello all! Today I'm going to talk about remote sensing and GIS technologies for eco-mining. First of all, let me introduce myself. I'm a researcher and also head of the department Mine Surveying and Geodesy at Kazakh National Research Technical University, named after Kanish Satpayev, which one is the oldest and largest technical university in Kazakhstan and founded in 1934 as Kazakh Mining and Metallurgical Institute. Since 2014, it has become as a research university, we have more than 10,000 students, 94 educational programs, master PhD programs in the mining, geology, industrial engineering, construction, mechanical engineering, geodesy, remote sensing, GIS, and another technical education programs, also in English. Thus, we are very welcome to foreign students. At the university, we have more than 7 institutes, and one of them is Mining and Metallurgical Institute. We are conducting different types of research regarding mining and also eco-mining. So, in this presentation, it's possible to see 29 different kinds of projects which are conducting right now in our institute and supervised by different researchers. Now let me talk about projects which I am supervising and about remote sensing technologies, how we are using it in the field of the mining. The first project is geodynamic monitoring. The aim of the project is ensure industrial safety in the territory of the mining enterprise by conducting comprehensive monitoring of geodynamic processes and the implementation of the received data in the format of the WebGIS. Research tasks. First, field zoning to identify potentially unstable zones. Second, carrying out observations by using GNSS data. Third, conducting retrospective analysis of the movement of the Earth's surface using differential radar interferometry. Development of WebGIS system. And so, first of all, we identified unstable zones by studying and analyzing of mining geological and mining technical conditions, determination of evaluation criteria zones. Then, by using remote sensing data, space imagery, I mean radar data, we have identified deformation of the Earth's surface and also conducted GNSS observations. All these results are validated by using GIS tools, and validation shows higher accuracy. And in the next slide, we are analyzing interesting moment. In 2020, there was sudden fall of the Earth, and classical terrestrial methods couldn't identify it due to absence of the observation points on this area. The remote sensing data allowed us to see previous state of this place, and having processed the earlier remote sensing data, we saw that in 2019, an increasing deformation trend began in this place. However, like any method, this technology has its drawbacks. And at the time of the sudden fall, I couldn't get information on the radar data for this area. However, after that, in 2021, we see that the deformation in this field is still ongoing. The next case is different from the first one. Here we have used remote sensing data and GIS for water monitoring. For investigation, we took seasonal small river close to mining area and investigated how useful can be remote sensing and GIS in these cases. We were used different water indexes and identified the square of the river, how it was changed over time. Then how vegetation in this area changed relative to water. And one more interesting point, it was possible to identify the indexes of chlorophyll in water and on grass. The result of change detection is shown on this small video. The third case study is, in the third case study, we tried to identify the minerals based on remote sensing data on the one of the mining area of Kazakhstan. The obtained result was evaluated by using the geological map and was quite good. However, we identified the shortcomings, and thus this method should be used in complex with ground-based observation. Thus, we can draw the following conclusions regarding remote sensing and GIS data for mining enterprises. The ability to cover large areas make remote sensing and GIS data incredible tools for monitoring Earth deformations. vegetation, and water change to take preventive action to ensure human safety and protect our environment. Thank you for your attention.
That was a very interesting presentation and talk. We'll now move on to the next speaker, Eshkurbonov Furkat Bozorovich, Associate Professor, Termis Engineering and Technological Institute, Uzbekistan. The title of their talk is Prevent Soil Salinization and Reduce Irrigation Water Consumption. I request you to raise your hand.
Good day, dear participants of this conclave and researchers. I would like to introduce my topic about prevent soil salinization and reduce irrigation water consumption. My name is Furkat Eshkurbonov, Associate Professor of Termis Engineering and Technological Institute in Uzbekistan. The first problem for learning this, we chose one region of Uzbekistan, Surkhandari. In October 2020, they has a total of 4.3 million hectares of irrigated land around Uzbekistan, and it was 44.7% of irrigated land to had varying degrees of salinity, including 31% weak, 11.9 moderate, and 1.9 strong salinity. In this percentage, we can understand that one of the biggest problem in Uzbekistan and Central Asia is salinity, and it became a global problem. The second problem, there is a total of 4.3 million hectares of irrigated land in Uzbekistan. 90% of potable water is used for irrigation. And my colleague Anwarjon mentioned before, the dry land area of the Aral Sea is 60,000 square kilometers. The total arable land area is 917,200 square kilometers, and this is clear effect for people in the agricultural system. Drought is prolonged period of weather in which evaporation exceeds precipitation. In such conditions, the water reserve in the soil is quickly used up, which has negative effect on the development and productivity of agricultural crops and pasture plants. Before a solution of this problem was being washed away the soil layer with a large amount of water, transferring them to lower of the soil. Elimination causing chemical agents. But nowadays we have many different modern ways which you see in this slide, such the lowest salinity was also observed in the fields with phosphorus fertilizers. Now we will overcome with huge money is lost in current artificial lakes, rivers and water reservoirs. Therefore, less drought is prevented. A starch molecule is synthesized from milliliters with the help of saving it. A polymer complex with a lattice solution is synthesized. Our solution for this synthesization was anions and cations contained in the polymer complex retain the necessary elements accumulated in the soil. Watering is reduced by up to 50 due to the long retention of moisture in the soil. Before mentioned, we will save not only time for also water resource. In this given slide, we can see beginning view of the field and then a wild planted in the year treated with polymer complex. Projection of production costs and net profit in the case of wheat in the 5 years period. Thank you for your attention. We hope this kind of research works will be helpful not for Uzbekistan but also for the countries where we can see soil problem, and we could cooperate to solve such issues.
Thank you for this wonderful talk on soil salinization. We'll now move to the next speaker, Urmanova Dilyara, senior researcher at the Kazakh National Technical University, Kazakhstan. And the title of their presentation is Basin Modeling Features of Southern Side of Precaspian Basin. I request you to raise your hand.
Greetings, dear participants and organizing committee of Young Scientist Conclave. My name is Dilyara Urmanova, and I'm presenting my speech in Environmental Protection and Nature Resource Management section with the topic Basin Modeling Features of Southern Flank of Precaspian Basin, Kazakhstan. In short, about our university, Satpayev University, one of the oldest educational institutions of the Republic of Kazakhstan. The history of Satpayev University, the flagship of the Republic's engineering education, is linked with the history of our state, its culture, and the system of higher education. The university was founded in 1934 as the Kazakh Mining and Metallurgical Institute. I'm presenting Department of Hydrogeology, Engineering, and Petroleum Geology. And in our department, we have several projects connecting reconstruction of the thermobaric conditions of the evolution of the subsurface on the basis of studies of liquid inclusions and rock crystals of the upper Paleozoic deposits of the east of the Precaspian scenic ice, geochemical analysis, and basin modeling. Proposal of study to consolidate disparate geological and geophysical information from over 300 oil fields over a period of almost 30 years to determine potential hydrocarbon pathways. During this project, I passed several internships and performed laboratory analysis, first in Kinfacht University of Petroleum and Minerals, College of Petroleum Geology, Dahran Techno Valley, Saudi Arabia. Here you can see pictures from laboratory and from internship. Second, past internship, performed laboratory analysis in Tomsk Polytechnical University. And third is University of Lorraine, Nancy, France. At this picture below, you can see the process of welding of gold cells for loading core samples of potential oil-producing rocks of super deep wells in order to carry out work on the artificial maturation of potential oil-producing rocks. Core samples from super deep wells, depth 7 kilometers, for new geochemical analysis, approximate budget for drilling and obtaining the samples, $7 million. XRD analysis of super deep wells samples, we see dominant mineral is calcite. Rock-eval analysis of super deep wells core samples. We see good results of TOC, total organic carbon in percent 2.83. With high values of residual carbon, RC parameter more than 2%, it's about 2.7%, which may also indicate the oil and gas properties of rocks that have realized their generation potential by now. Most likely, this is due to a high level of thermal transformation. This is confirmed by the values of TOC, which is mainly represented by residual carbon. Thus, the samples of the above wells can be considered potentially source rock wells, but now, by now they have fully realized their generation potential. For such rocks, it is possible to establish the type of kerogen and restore the initial values of the generation potential and the content of organic carbon. It's impossible to determine the type of kerogen and the catagenesis of these samples from pyrolytic data. To solve this problem, it is recommended to conduct isotopic studies of decarbonized rock samples. Determination of the level of catagenesis according to pyrolysis data, we can see good results of our samples. Overview layout of the study area containing more than 300 oil fields. Structural and tectonic map of the foundation of the southern block of the Precaspian Basin. In detail, it's a Trugai block, which include Kashagan, Mahambet tectonic stage, southern tectonic stage, Tengiz ledge, south ambient tectonic stage. The object of our interest is several oil fields as Karaton, Tajigali, Pustinna, and Sagan, Tengiz oil fields. A scheme of correlation of Carboniferous and Devonian deposits of flank zone of Precaspian Basin, where the main oil-containing zones are for Carboniferous period and potential source rock zones in Devonian. The research gap in this study, that is a lack of geochemical parameters and difficulties to obtain new core samples from different international subsoil users. Correlation scheme of Carboniferous and Devonian deposits of the southern flank of the Precaspian depression, compiled by Belkasimov. A regional section for the structure studied, indicating the capacity of the carbonate platform at Tajigali, Pustinna, Ansagan, and Maksat oil fields, and the possible direction of compression, red arrows in the lower left figure, that formed the Ogai and Northern Kultuk structures. The main tectonic sinking that affected the flooding of the Ansagan and Maksat structures began in the late Devonian, early Carboniferous, and continued until the late Carboniferous. There is an increase in the thickness of Carboniferous deposits from Ansagan to Maksat. According to an alternative seismic interpretation, the flooding of Maksat and Ansagan could have occurred due to heavy precipitation from the shelf on the southern southeastern margin of the sedimentary basin, which caused a deterioration in water transparency. Therefore, the depth of flight penetration decreases and carbonates did not keep up with sea level rise. Regional geological profile in the west-east direction through the Tengiz field and the Ansagan 1 well, showing the main perspectives of those fields at the depth of approximately 5 kilometers, Carboniferous period. Backstripping procedure of paleoreconstruction, they've shown the evolution of sedimentary Precaspian Basin, starting with Devonian period and ending with a Triassic period. Scenario for calculating the reflectivity of Veterinite, and scenario for modeling the migration of hydrocarbons, showing the pathways. At the end of this project, several publications were performed showing different conference and journals. In acknowledgements, this project was funded by the Committee of Science of the Ministry of Education and Science of Republic of Kazakhstan with a budget of more than $100,000. And my thanks to academician Abulhasimov, academician Ozdoev, my PhD advisors, Professor John Humphrey and Professor Raymond Michelis. Thank you for your attention. If you have any question, I would love to answer them.
Thank you for the excellent talk. With this, we have reached to the last talk of this session by Parmonov Sarvar Toshpulatovich, Associate Professor, Tashkent State Technical University, Uzbekistan. The title of their talk is Importance of Hard Alloys in the Management of Natural Resources in Uzbekistan. I request you to please raise your hand.
Good day, dear colleagues and participants of the event. I am Parmonov Sarvar, Associate Professor of Tashkent State Technical University, Uzbekistan. I am honored to present you my topic on the importance of hard alloys and the management of natural resources in Uzbekistan. My research is focusing to develop the life of crushers used in extraction of underground resources. As we know, Uzbekistan is one of the first countries in this field. Approximately 200 million tons of underground minerals are mined and processed annually, such as gold, silver, copper, molybdenum, and radioactive elements such as uranium oxide. And most of the mineable underground resource which we before mentioned and Nawae mining and Almalik mining metallurgy combines. The process of natural resource is very expensive and rotor crushers are widely used in the process. The main working organ of rotor crushers is the named thing's finger. Here you may see Semco rotor crusher. Production capacity is 220 tons an hour. And the next given picture shows the finger, which is the working part of the rotor crusher. Finger length 232 mm, diameter 38 mm, weight 4200 grams. These tables indicate the chemical composition of metals that make up the finger. Tungsten carbide powder is composed of 96% tungsten and 6% carbon. The amount of addition elements in cobalt powder is 0.75% and in titanium carbide powder is 0.5%. As a third picture, general view of an abrasive worn finger. In order to study the abrasive wear of fingers, we studied the chemical effect of an abrasive particle hitting the finger. In next picture, photo of piece of this finger magnified 1000 times and their chemical compositions presented. The effect of abrasive particles is very important in the process of abrasive wearing of fingers, and the results of the experiments are shown in picture 5 and 6. Picture 5 on this slide shows how abrasive particles attack on finger. In next picture, you can see parts of the abrasive worn surface magnified by 2000, 300, 4000, 6000 times in the electron microscope. In this slide, you may see technology for sintering hard alloys. Ultra-dispersed titanium carbide-based hard alloy samples were sintered in two stages. There were initial sintering and final sintering. Initial sintering temperature was 700 degrees Celsius and the final sintering temperature was 1350 degrees Celsius. Vacuum was 13.30 multiplied 10 raised of the power of -6. The samples were cooled together with the furnace. The table shows the influence of the amount of tungsten carbide, cobalt, titanium carbide in the samples and on the degree of density and porosity of the samples were studied. sample centered from 1350 to 1380 degrees Celsius have high density and low porosity. Picture 7 shows shrinkage of hard alloy samples. Now, samples with the addition of 5% ultra-dispersed titanium carbide were centered and their chemical composition was determined under an electron microscope. As can be seen from this table and graph, the density of the samples decreased as the amount of ultra-dispersed titanium carbide increased. The tests showed that the samples centered at 1380 degrees Celsius are harder but more brittle. Well, picture 10A and B are given information. The hardness and bending strength of the samples increase with an increase in the amount of ultra-dispersed titanium carbide. Next one shows an image of semiconductor crusher, and the table compares the working life of existing and new chemistry fingers. As can be seen from this table, fingers with a new chemical composition are 25% more productive than currently in use. Conclusion: based on the conducted scientific research, we concluded that the introduction of up to 5% of ultra-dispersed titanium carbide into hard alloys based on tungsten carbide increase the mechanical and operational properties of hard alloys. Thank you for your attention. I am open for discussing and joint research.
Thank you for that very interesting talk. With this, we'll now move on to the question and answer session. I request that the participants present here raise their hands, and our volunteers will come to you with the mics. For the online participants, kindly type in your question in the chat box, and we'll take them at the end of the entire session.
I have a question for Dr. Mingkai Jiang. Are you available? Are you online?
Yes, I'm online.
As you are working on model for predicting elevated CO2, so in recent condition due to urbanization and globalization, atmospheric CO2 is increasing, which results into increasing the crop productivity as you have mentioned. But at the same time, elevated carbon dioxide results into global warming, and global warming results into decreasing crop productivity in several regions. So I would like to know what could be the net effect globally by elevated carbon dioxide on crop productivity.
So your question is what's the net effect of global warming on crop production?
Yeah.
I think it varies by region because, as you know, plant respond to temperature rise in a non-linear way. So that's a optimum temperature for photosynthesis, for example. So as temperature increase, initially you would see an increase in photosynthesis, but gradually that will decrease once the thermal optimum for photosynthesis decreases. But at the same time, increasing temperature also increase restriction. So I think there's a consideration as to what individual plant species will respond to the mean rise in temperature. And adding on top of that is the climate extreme, so heat wave and cold temperature range. And I think with that, you would say that it's a complicated issue, and I wouldn't say it's it's going to be a net change of X or Y, because it varies by region, it varies by time scale.
Thank you.
My question is to you only, Mingkai. So how do you make the ensemble of multiple models? Is it weighted average or simple average? What was the methodology?
Right. So initially we need to run the individual models, as you may have already know. But for our purpose, we are not really interested in the multi-model mean, because that doesn't really tell us the mechanism behind the prediction. And therefore, we want to understand what the individual model are doing in terms of the underpinning process in the models. So we didn't really calculate the multimodal mean. Instead, we try to understand the workflow in each model and how that actually predict, how that link to that prediction. So it's not a multimodal mean in our evaluation.
So means how did you derive the ensemble then? Ensemble of models?
How do I derive the ensemble of the models?
Yes.
We select the models that are representative enough of different processes that are currently incorporated in different land surface models. And then we did not calculate the multimodal mean, as I just said before. We just was interested in the prediction mechanism instead of the accuracy of the prediction, because this is just one site. We can't use one site to evaluate the model, but we can use one site to evaluate the underpinning mechanism in the model.
Again, I can't see the validation results with your field data, the model output and your observational data. So have you validated your model output with observational data?
Yes, we are trying to evaluate the model prediction against the observational data, because we run the model under both ambient CO2 concentration as well as elevated CO2 concentration. So we can evaluate the model prediction against the ambient CO2 concentration data. And then we just look at the prediction for the elevated CO2 response.
Are there any other questions?
This is Kalashnikova.
Please go ahead.
Yeah. You have mentioned that a lintisite group can be used as a photocatalysis. So that this is at what wavelength? Is there any? Is a semiconductor type, or what is that material here?
You mean the photocatalysis or heterocatalysis?
Photocatalysis.
Photocatalysts. We try to investigate the substance of our materials for this area, but for nowadays, we can't register the good results in photocatalysts. But as we use our material for heterocatalysis, it will be better, but not for photocatalysts.
Okay, so you mean you are having the titanium, so based on that you are thinking it's photocatalysis?
Yes, this material includes a lot of titanium, and maybe it will be possible to use it in this area, but we try to do some experiments, for example, with the organic colored solutions, for example. And yes, and we try to give the mark, for example, with the base of titanium oxide. Maybe you know the mark Degussa, for example, P25. And this material was better than our materials for photocatalytics.
I see. And the other one, what range of the surface area you are getting with this type of materials for catalysis? Surface area?
Maybe, but I can't right now answer on this question about the photocatalysis.
No, surface area of these materials.
Surface area. Yes, surface area is very different. If we would like to say about the initial substance as AM4, for example, it will be more higher surface area. It will be near the 62 meters, yes. Or if we will talk about the material which have been treated by the acid, it will be lower.
I see. Okay. Thank you.
My question is to you as well. Your presentation was very nice. Just out of curiosity question, that the new compound that you are talking about, do they find in future any medicinal or clinical use, do you think?
For clinical use?
Yes.
You mean the medicine area or not?
Yes.
The medicine area.
Yeah.
For medicine area, we try to give them maybe some ways for futures, as we will use it with only for this material, with silver cations. When we modificate our crystal structure of initial material with the silver cations, and maybe it will be useful to use it as a the material which can be useful for biological just a second, microbes, to close the active of the microbes, for example. And it's known that in literature for initial material as an aim for the scientists from Portugal have already used it for this in this area.
Interesting. Thank you.
Thank you.
For the participants who are joining us online, if you have any questions, please type them in the chat box. Do we have any more questions from the offline participants?
Thank you very much. I mean, those were excellent presentation. I noted a few questions in the panel discussion. When I come there, we can ask in detail. So thank you very much.
With this, we come to the end of the question and answer session. I thank all the participants for the active participation. We shall now break for tea outside. Our volunteers will help you with the same. I request everybody to assemble back at 11:45 for the rest of the talks. Thank you.
Hello, can I make one announcement, please? Yeah, day before yesterday, Dr. Arvind Kumar told that we need one-page brief on each thematic area. I hope you guys have coordinated among themselves and your a brief summary of each thematic area is ready. Like all those participants who presented in disease biology thematic area, they need to give us one-page brief after discussing this among themselves. So have you guys prepared? Yeah? Yeah, we need it today only. It's AI you have submitted to whom? All right. And then disease biology and healthcare? Okay, you can email it to me or to Dr. Arvind Kumar. And then there's one more theme, sustainable energy and energy storage. Who all were the speakers in that theme? Sustainable energy and energy storage, yeah. You must have been coordinating with all your other participants of your theme. Dr.